It's the Packet Thrower! Welcome to the channel! Hey guys, I haven't recorded in quite a while, so to make it up to you, how about I do a bit of a super fun variety hour covering NetDevOps, and it's going to be quite the monster video there. We're going to talk about all kinds of different tools there. I have no idea how long it's going to take me to put together, but this is a long weekend, so let's have some fun here. Some of the tools we're going to be talking about are Packer and Vagrant. These are made by HashiCorp, and this is going to create some images for us, and then we're going to use those to create our virtual machines. Then we're going to configure those virtual machines with Ansible, which is an infrastructure as code tool. And then when we get all that working, we're going to use GitLab's CI/CD, that's continuous integration and continuous deployment, to automatically deploy our routers for us. And lastly, we're going to use Alexa to let me say some words and have the lab be torn up and brought down. Okay, so what we're going to be building out today is a simple spine leaf network that's going to be running OSPF there. So we're going to have 2 spine routers and 3 leaf routers. Now, normally we do switches for these there, but I'm going to be using VyOS as my virtual router. And just for the fun of it there, I just did some VyOS certification and I have the lab built, so I figured why not share it with you. So this is the page where you download VyOS. And we can see here that this is the rolling release there, which means that pretty much every day they release a new version. So what I'm going to do is I'm going to download the latest version, and this is actually hot off the press there. This just came out. And then I built the topology in GNS3 so that we can get familiar with the command line stuff that we're going to be automating later. So I'm just going to go ahead and start these up. So this is the booted VyOS there. I can log in with VyOS and then VyOS. And then the first thing I want to do is actually install the image. So I'm just going to say install image. And we're just going to go through this installer. And what this does is it takes the ISO and installs it on the hard drive. If you don't do this, then basically it just runs as a live CD there, and it'll be wiped out if you reboot or anything like that. So we need to enter in an initial password. I like to just use a standard lab password. I think I missed it there. Third time's a charm. There we go. So now that's installed, we're just going to go ahead and reboot that. And now that's back up, I can log in with VyOS and then my new password. Now that I'm logged in, we can do the configuration. So what we want to do is just say configure. And then the command structure for this is a mix between Cisco and Juniper there. So we have our set commands like Juniper does, but the actual logic tends to be somewhere between Cisco and a Juniper for when we do things like reference command lines, network statements, that kind of thing. So the first thing we want to do is set a host name. So that's going to be system, host name. This is going to be spine01. And then we want a domain name. So the packetthrower.com. And if we want to do things like make sure we have DNS, not what it matters for the slab, we can say name server and put it by name servers. Okay, so now we will do our interfaces. So we'll say set interface Ethernet, and then we can pick our Ethernet here. So basically it's going to be connected. So Ethernet 1 goes to leaf 1, Ethernet 2 goes to leaf 2, Ethernet 3 goes to leaf 3. We're just going to say ETH1 address. It's going to be 10.1.11.254/24. 2 is just going to be 12. And 3 is going to be 13. All right, so you notice how nothing is being applied yet because I actually have to type commit for this to work. So I'm just going to say commit here. And if I look, I can say run show interface. We have our IP set, but we can see the host name is not changed there, and that's just because we need to refresh it there. So if I just go exit, we can see that we have that refreshed. So I'm just going to go back over here. And then the last thing I want to do for this simple lab is set up a loopback. So we're just going to say loopback address is going to be 192.168.255.1/32. So one thing to point out is in VyOS, you can only have one loopback address there, but if you need to have fake networks like you can in Cisco there, you can use a dummy interface there. So if I wanted to, I could say interface dummy, and I would just call this dum0 is going to be 10.1/24. So now we have our interfaces set up. We can go ahead and set up routing. So it's going to say OSPF, area 0, network, and then we pick our networks just like we do in Cisco, except for this isn't a wildcard mask, this is a subnet mask. So we'll go commit, and we'll go save. So I'll pause the video here and get the other guys up and running so we can see what working OSPF network looks like in this platform. And then when that's done, we'll look at how to automate this. Okay, so everything is up and running. So if I do a show IP OSPF neighbor, we see we have 3 neighbors, which if we look back at our GNS3 here, we can see that each spine has 3 leaves connected to it. And then we can do a quick show route, and we can see that we are learning our leaf loopback addresses, which will be handy for spine leaf architecture. But we're not going to get too deep into the actual routing side of things there. We're going to be focusing on the automation side today. So with that, let's look at our first tool. First tool that we're going to be talking about today is Vagrant, which is made by a company called HashiCorp. And what this does is it automates virtual machine creation. This is useful if you want to do testing as a developer or someone in DevOps, because what it does is lets you create a virtual machine with certain parameters. Then you can do whatever you want to do with that virtual machine. And then when everything's done, you can destroy that environment and then have it created next time you need to run things there. So everything's always clean and ready to go. Now there are 3 components that we need to concern ourselves with Vagrant. There is the box file, and what this does is basically it's just a package that has all the virtual machine files that you need, so that if you're spawning a virtual machine, it has all the source files and stuff in it. And it's customized in a way that Vagrant can do its work. The Vagrant file describes what is actually going to be done by Vagrant there, so it's going to tell it how to actually create the virtual machine and whatnot. Now this is based on Ruby, so if you know some of the Ruby syntax there, you'll be able to do some loops and that kind of fancy stuff. And then the last thing I'll mention is plugins, and this extends the functionality of Vagrant there. So for example, we're going to be installing the VyOS, we're going to be installing the Vagrant VyOS plugin, and this is just so that Vagrant knows how to detect VyOS there and how to interact with it. Otherwise, it's going to think it's a Linux there, and the provisioning is going to mess up. So this is Vagrant's site. You can see that it's available in pretty much any operating system that you care about there. It's in Mac, Windows, Linux, and then certain flavors of Linux there if you have different architectures. And it also supports 32-bit or 64-bit. I always use 64-bit for everything there, but you might need 32-bit for some reason. Now, I will point out there that there is a ton of docs on HashiCorp there. They give a lot of tutorials, and all this stuff is free for you to play with there. So if you like what you see in this video, you might want to play around with it in your lab a little bit. So I'm actually going to be doing this with my Windows and WSL. I'm going to be using both parts of it there because I'm going to use VirtualBox for the virtualization, and then I'm going to use the WSL for the Ansible portion. To install this on my Windows, I use the Choco manager, so I just need to go Choco install Vagrant. I already have it installed there, but you can see that I can have the latest version, and I can reinstall it if I want to. And while I'm here, I'm just going to also install that plugin. So I'm just going to say Vagrant plugin install Vagrant VyOS. And I probably already have this one too there, but this is what you do to actually get it installed. You need to do this, otherwise it's going to fail when you run this there. It's not going to be able to detect the OS. Now for the WSL side, I just need to go to my Ubuntu here. And the trick is I need to have the same version of Vagrant installed, and then there's a variable I need to add. We can go back to our site here and click on Debian. And I'm just going to go ahead and copy this link. So what I'm going to do is I'm just going to say wget, paste that in. And then I'm just going to say Debian package manager install Vagrant. There we go. Okay, so that has been installed. And really all that does is it downloads the binary into the user bin vagrant file. They're all the HashiCorp files like this. It's a single binary. So you could actually just download this, put it yourself, and change permissions. They're up to you. If we look at the bottom of my bash RC, we can see there's two very important variables. The first enables WSL to work with Vagrant there, so we need to add export WSL enable Windows access and then set that to 1. And then the other one, when we get to Ansible, is we're setting the cow selection to random there, and that's just going to make things a little bit more fun when we get there. And then, of course, we just source this there or just log in again, and then we'll have access to this. So let's have a look at the actual boxes we can install. So this is Vagrant Cloud, where they store all the public boxes that you can use. And remember, the boxes are really just packaged up virtual machines that Vagrant can work with. So we can see we have some of the common ones you would expect, like there's Ubuntu and there's CentOS and Debian, if you just want a vanilla virtual machine. Now there's a ton of stuff here, and we can break this down by the provider. So right now this is using VirtualBox, which is what we're going to be doing for our lab. But if we hit 1 or 2, we could also do VMware. Now, if you do the VMware, you do need to buy a license for the VMware Workstation and Fusion. It's about $100. I use it all the time there, and we're going to have to do some workarounds to get around that fact. But the VirtualBox is free, and it's generally well populated for images, so we're just going to focus on that. We can search for whatever we want. So, for example, if I search for VyOS, we can see that people have uploaded their own boxes there, and we can see that they're older versions, not quite what I'm looking for. So we can see that there is no current one there, because remember the goal of this is I want daily providers to be downloaded, so my lab is always current. So we're going to be making our own, but first let's just explore how this works. Let's just go back to Ubuntu. And we're just going to click on the Ubuntu page. And if we want to see everything that's available, we can just click on the left side. And then if we want more details on the provider, we click on the right side. So we'll click on the vendor name. We have everything from the latest release, which is 2110 or Impish. And that was released 2 days ago. And then we have some older stuff there if we need to do some testing on older versions of an operating system for some reason. So let's just go ahead and pick Impish. And what this page does is it tells you how to use it there. So this tells you how to make your own Vagrant file. And what we need to do is put this in, and then it would generate the box when we initialize it. Or if we want to create a Vagrant file, we can click on the New tab, and it's just going to say, hey, do Vagrant init, and then add this in, and this is going to generate a Vagrant file for us. So let's have a look what that looks like. So I'm going to copy this, and I'm going to go over to my WSL. With my WSL, we're just going to create a working directory. So we're just going to say make your Vagrant, and then we'll cd into it. And then we're going to paste that command, which is the Vagrant init Ubuntu Impish 64. Now all this is going to do is going to create a Vagrant file for us, and then we can have a look at it. We can see that it has placed a file in our directory. We can see it's there. And if I cat this, we can see that it has provided a basic configuration. It is calling our box, which is what it literally just took whatever I typed and pasted in here. I could type anything I want. It's not going to validate it yet until I run it. And then it's just going to explain some common options that you might need to care about. So what we're going to do is I'm actually just going to remove this. Now you've seen that it provides a bunch of comments there for how to do things like provisioners, which we'll talk about later. We're just going to do the same command, but I'm going to do a -m for minimal, and it's going to be the same thing except for it's not going to have the rest of the comments there, so it's just going to be a much smaller file. So I'm going to edit this file. I'm going to go Code Insiders and then Vagrant, and this is going to open VS Code. We can see that it's declared itself as Ruby and that VS Code is detected as Ruby. And then we can walk through what it's doing here, which isn't a lot. It's saying we're defining that we're using the API version 2 for Vagrant. Right now, everything is API version 2. Hypothetically, HashiCorp might make a version 3, but for right now, everything's 2. And then anything in the pipes is defining a name for how we're going to reference the bottom stuff there. So we see how up top we have config. And then anything we want to do to reference the Vagrant would be config there. And as we define other parameters, this will change as we go there. So I mentioned before that I have the VMware Workstation plugin as my default there, and I want to run this as VirtualBox there. So I have to do some extra configuration that you might not need to do, but I need to tell it to explicitly use VirtualBox. And I do that by saying config VM provider, and then I just say VirtualBox. Now, I can also do some other customizations. So I can say do, and then in my pipes, I'm just going to say V. So now anything to do with VirtualBox is just going to be referenced by V. And then I'm just going to say set the CPU and RAM. So I'll say memory is 1 gig. The CPUs is going to be 1. And then my serial port of my VirtualBox is acting up for some reason. So I'm just going to disable it so it doesn't mess with us. So I'm just going to say V customize. And this is how I directly modify the virtual machine. You don't normally need to do this. It's just right when I started recording there and I tested this out, it started freaking out. So this is the workaround. So say modify VM. The ID is going to be passed to it. And then we need UART mode 1 is going to be disconnected. When we open up a block like this, we need to end it. So we type end here, and this end is going to be terminating this block, and this end is going to be terminating the main block there. So we always want to make sure that we're terminating any function that we open up here. There is one other configuration we need to do here, and that is to turn off the shared folder. The shared folder is a feature where Vagrant will automatically share a folder from your host to the VM for convenience, but the WSL doesn't support that, so I'm just going to turn it off. And we do that by just saying, we'll make a comment. You can say disable shared folder, and then we're just going to say config VM sync folder. And by the way, there's XMA documentation on HashiCorp there. You can learn what all these parameters are as you go. And then we're just going to say Vagrant is disabled. So how to read this is saying that the config, which remember is referencing the Vagrant, the VM, the synced folder is the parameter. The current directory where the Vagrant file is by default going to be shared to the /Vagrant folder on the virtual machine, and we're just going to disable this. So with all that, we should be able to save this. I'm actually just going to add a comment here so it's more readable for you guys. So we'll say customize vbox provider. We can add comments to make this a little bit cleaner, and we can move this around as we need to. But this is a basic file, so we're just going to save this. And I'm going to go back to my WSL. And we're going to say Vagrant up. We can see it is downloading that box because it's from the public cloud. And it is customizing the VM and booting it. You can see it's waiting for the virtual machine to boot. And here, it actually logs in with an insecure private key for SSH, and then it replaces it with a newer key for security purposes. So you can see there that it's using the insecure key, it's generating a new one. Now we're going to have to turn this off when we get into the actual VyOS there because the network appliances don't understand this. So at this point, if I open up my VirtualBox in my Windows, you can see that this virtual machine is running and it has an ugly automatically defined name there. We can change this if we want to, but this is fine for our purposes. And then if I want to work with this, I just go Vagrant SSH. Now I am brought into this virtual machine. So I can do anything I want on here. I can see, say, my IP address. I can update the packages, and everything works the way it should. Now, this is really cool because I just created a virtual machine in a couple seconds in the same way that we might create a container in Docker. So this is very nifty for playing around with things. So when I'm done with that, I can just go Vagrant, destroy, and this is going to automatically tear down the virtual machine. Now, this is obviously a simple example. I just did one virtual machine, and it's not that big of a deal there. But if I wanted to, I can create dozens of virtual machines as part of a single file there, and I can have them all spun up, provisioned, and torn down. That's exactly what we're going to be doing with our lab there. Now that we used Vagrant to make an Ubuntu box, let's get back to the task at hand and make one that we can use for VyOS. So to do that, we're going to create a virtual machine for VyOS, and then we're going to customize it a bit so that Vagrant can connect to it and do what it needs to do. And namely, what we need to do is we need to make sure that the virtual machine gets an IP address, and we need to add the insecure public keys there so that it can connect to it. So I'm just going to go ahead and go new virtual machine, and I'm going to call this VyOS template. And then we're just going to say that this is Linux and that we want Ubuntu because VyOS is based on Debian at the end of the day. So a gig is fine for VyOS. And we're just going to go ahead and create a hard disk. VDI is fine. And we're going to dynamically allocate it. And then we're just going to go ahead and say 10 gigs. That's plenty for VyOS. Okay, now at this point, we don't need to customize much because the first adapter is a NAT by default. Now, the first adapter has to be NAT for this to work there, so that's already taken care of there. But if you have different default configurations, you might need to adjust that. However, we do need to add ISO for it to boot. So I'm going to right-click and go Settings. And we're going to go down to Storage. Go here, and then we're just going to say mount this. I've already done this when I was playing around earlier. Go OK. And now I should be able to boot this by double-clicking it. And we're going to sign in. Now the first thing we need to do is actually, we should install it first. So we're going to install it. You can see that it is giving us a warning that it's in the live ISO there. So had I not done this there, everything would have got wiped out when we shut it out there and we wouldn't have got anywhere. So we're just going to go for this. Just basically say yes to everything. Give it a password. And we'll go ahead and reboot this. What I'm going to do to make life a little bit easier on myself is I'm going to change the network to bridged so that I can easily SSH into this. And then I can do the configuration, and then we'll just change it back before we do our conversion. So I'll sign in. And what I want to do is enable SSH. And then we want to give our first interface DHCP. So I should be able to log in with this. All right, so this is me connected to the virtual machine through SSH. So what we need to do here is we've already enabled the DHCP on the first interface so it gets an IP, and we've enabled SSH. And the last thing we need to do is deal with the insecure key. So this is the GitHub for Vagrant. And if we look under the keys, we can see we have the public key and the private key. We don't really need the private key because this is going to be in every Vagrant installation. We just need to make sure the public key is represented inside the VyOS VM. So I'm just going to go ahead and copy this, and I'll paste this in here so that we can edit it as we need to. I'll get this out of the way, and we'll go back to our SSH. What we want is we want to go to System, Login, User. We're going to call this Vagrant. We're going to give it a full name. We'll just call this Vagrant. That doesn't really matter to anything. And then we'll go back over here, and we want Authentication, Public Keys. So we're going to give this a name. I'm just going to call this Vagrant Insecure. Then the type is going to be SSH RSA. If we look back over here, this is the type here. And if we go to the very end, this is the label. Now, this doesn't need to match, so I just called it Vagrant Insecure instead of this long name. So this is the actual key. So I'm going to copy this. Get an extra space there. I'm going to copy this. And we're going to go back over here, and we're going to say the key is this. So I'm going to go commit and save. We'll look at what we did here. So we'll say show commands. We see that we have our Vagrant application public keys, our name, and then this long key is what I pasted in. I also saved the configuration. So we should be okay here. And actually, before I save that, I'm just going to add a plain text password there because sometimes the WSL gets a little bit wonky. And we just want to make sure we can access our VMs. So I'm just going to say logon user Vagrant authentication, plain text password, and the password is just going to be Vagrant. I'll commit this and I'll save. At this point, I'm ready to change the network back, and then I can make a box out of this. Then we're just going to go ahead and reset the virtual machine. Now, we're going to go to a directory that I can work with. We're just going to call this Vagrant, and then this looks clean. So inside here, we're going to say Vagrant package. And what we can see, we have the base and then the output. So I can say base is going to be the name of the virtual machine, which is VyOS template. And output will be VyOS.box. If we look here, it is shutting down the VM and it is exporting the contents for us. And now that's done, you can see that it is here. We need to make a JSON file so that we can add it properly. So I'm just going to say code insiders VyOS.json. And this is what we're going to put in the JSON there. So this is just going to give all the attributes we need. So the name is just going to be VyOS/current, and we're going to say the description is 1.4 because that's the current branch. And then we're just going to say that 1.4 is the version. And then I just point it to the box. So I'm going to save this. And then what we do is we just say Vagrant box add, and then we point to the JSON file. So it'll be VyOS.json. And now I should be able to use this in my configurations. Just see all the boxes I have. So say Vagrant box list. And we can see we have VyOS current and then 1.4.1 there. So basically the most recent version will win. So if I wanted to, I could add 1.4.1 there, or I could just continuously replace this depending on how we go there. We're going to be doing this in a different method in the next part of this video. But for right now, let's just test this out. So we'll go back to our WSL. And we are going to open up our Vagrant file here. And all we're going to do is change a couple parameters. First things first, we've got to tell it which box to use. That's VyOS/current. And then we also need to tell it not to replace that insecure key because VyOS doesn't understand what it's trying to do there, and it's just going to overwrite things. We're just going to say disable SSH key replacement. And all we do is we just say config SSH insert key is going to be false. So with that, I should be able to close this and go Vagrant up. Well, now that's done, I should be able to go Vagrant SSH. And as I mentioned here, the SSH can be a little bit wonky with SSL, so we're just going to enter in that password I set. And now we're in the VyOS. So now we have a single node with no real configuration in it. So we're going to go ahead and destroy this. And then we're going to have a look at a more complicated file. As a quick reminder of what we're doing here, we created one virtual machine with no configuration, but our end goal is that we want all 5 of these virtual machines created, and we also want the configuration applied too. So with that in mind, here is a more complicated Vagrant file that I put together, and we're just going to walk away through it. The first thing I like to do is I like to define the API version as a variable and then define it here. And that way, if they ever change the API version, I just need to update a file. Presumably there'll be a bunch of other changes, but I just like to do that for cleanliness. And then we have our box defined. We have to save our SSH key like we did before. This is something I haven't done in the previous examples, but what I'm basically doing is just telling it not to update any plugins. And the reason for that there is because this is a private box error and there's no point in trying to update things. We're just saving the shared folder like we did before. We are defining the parameters for the box. We're defining our memory and our CPUs, and I'm also just going to copy and paste that workaround just in case it bugs me again. And now, after we've defined everything there, this is something that's new. I'll skip this part, I'll talk about that in a minute. We're going to scroll down, down, down. What I've done here is I've created a for loop. So what I've said here is create 2 instances of the spine. And anytime you see a pound sign and then a variable reference like this means it's going to be a substitution. So basically, this is going to create spine 01 and then spine 02. Then I've also defined some networking here. So this is how we're actually going to configure the interfaces to be connected to each other. So basically I'm saying that spine 1 to leaf 1, leaf 2, leaf 3, and then spine 2 to leaf 1, 2, and 3. I'm also changing the interfaces a bit there so that they are promiscuous, and that's just so that some features in the networking work the way they should. And then I am calling a provisioner. Now the provisioner is a shell script I'm creating. And what this is doing is pushing the configuration down in a way that VyOS understands it there. So I create this file here that has all the configuration in it. And this is used something called vbash, which is Varieta, and we have to source it a certain different way. And we have to source it a certain way for the code to work. And then if we go down here, you see that I apply the template there in a way that VyOS understands. And we do the same thing. Oh, I should have actually showed you this side. This is for the spine. Same configuration though. And then for the leaves, basically the same thing, except for they're called leaf. And I'm editing it so that each leaf has one connection to each spine. Same idea. Leaf scripts is all basically the same thing of defining the interfaces and enabling OSPF. And that is all it is. So much longer configuration, but we are basically just adding some loops and applying a provisioner. So with all that said, I'm going to save this. And then we're just going to do Vagrant. This is going to take a few minutes to run. We should end up with 5 virtual machines by the time this is over. Okay, that's being completed. You can see that we now have 5 running VMs, so 2 spines and 3 leaves like we want. Now, before we always just typed Vagrant SSH because there's only a single node, but now we have several, so we need to see what the names are. Now the names are just going to be what we defined in the configuration in the loops. So we can see if we have leaf 03, so we have spine 1, 2, and then leaf 1, 2, 3. So we see we have the running the states here. I can stop them. I can store them if I want to. I can do particular things with them. But let's just look at the first spine. Say Vagrant SSH spine 01. And again, because of the WSL problem, I'm going to click in. I'm going to have to enter in the password. And now we can see that we have our host name, so this looks promising. I check our interfaces. We have our interfaces configured. And if I check OSPF, I have 3 neighbors. And last but not least, our routing table. And last but not least, our routing table has our OSPF rows as expected. So cool, that worked really well. So this phase, I am done with these, so I'm just going to go ahead and so the batch provision in the previous example worked pretty well, but the downside to that was that it led to a pretty large Vagrant file because we had to paste all the configuration for each individual node and it didn't scale very well. So instead what we're going to do is we're going to talk about using Ansible as a provisioner. And because of all the files and stuff we're going to create to support this we're also going to talk about GitLab to use that as a repository to start holding our files. So this is my GitLab page. We're going to be using this for storing the code there and later for doing the CI/CD stuff there for our final parts of this video. I could have used GitHub there because they have similar functionality, but I flipped a coin and we're using GitLab. So I'm going to go ahead and create a project. And we're going to create a blank one. And for the name, I'm just going to call this VyOS GitLab. And then I'm just going to keep this private so that I don't have to worry about any keys leaking or anything like that. So we're just going to go create project. So I'm just going to clone this into RubyMine, which is a Ruby-based editor because we're focusing on Vagrant right now. And all we have right now is our README file because it's just an empty repository. Now what we need to do is I need to grab the SSH keys from my WSL because this is a new project. So I'm just going to go SSH id.public. I'm going to copy this. Okay, so now that I have the keys copied, what I want to do is go over to GitLab and then go to Preferences. Then I want to go to SSH keys. Then I'm going to paste them in here. Call this home WSL. And I'm going to paste in the git clone command. So now I have the repository in my WSL and also on my desktop there so I can edit things. Now what we're going to do is we're first of all going to create a new Vagrant file. I'm just going to say File, Vagrant file. We're going to add it to the repository. And we're going to paste in what we had before. So the logic is largely the same, except for we don't need any of this stuff there, and we need to tell we're using Ansible. So we're going to delete our scripts. And we're going to remove all this provisioning stuff. Like so. And like so. One of the things I like about the JetBrains tools there is they understand the flow here. So you see if I click on the end, it will match it to the proper due so I can see if I'm missing an end statement or something like that. So now we have our basic framework. We just need to work on the Ansible bits. We need to add a section for the provisioner. So we're just going to say config VM provision. Now we're doing it at the bottom here because we want all the VMs to be created before we get into the Ansible stuff. So this is going to be Ansible, do, we'll just call this Ansible, Ansible.playbook, I'm going to call provision.yaml. we have to make a couple modifications here because Vagrant will automatically create the host file for us there, but it's not going to create it in a way that's going to detect the VyOS there, so we need to tell it to configure things properly. So we need to help it out a little bit. And we do that by saying Ansible.groups. So what we want to do is edit the all group there so they're all applied to the same thing there because router in this configuration. We'll say all vars. And then we're just going to say that, and then we're just going to call, first we have to say that the Ansible connection is using the network CLI. So that's going to be Ansible connection. And then that's going to be Ansible net common network CLI, because Ansible in their infinite wisdom decided to make names much longer because everything's a module now. And then the other variable we need is Ansible network OS. Is going to be VyOS. All right, so now our Ansible is ready to go, except for we haven't actually configured the playbooks yet. So what I'm going to do is I'm going to commit this, and I'm going to push this to the repository so that we can work in my WSL. So we're just going to say first commit. And I'm going to go ahead and push this. Then on my WSL, I'm just going to say git pull. Now we have my Vagrant file. Now I already have Ansible installed. You can install it with pip install Ansible if you need to. Now with Ansible, we can do one single playbook for everything, or we can do roles if we want to break things out there. We're going to go with the role method there, so it's a bit more clean at the end of the day. So the easiest way to make roles is to go Ansible, Galaxy, then we have collection, which is how we install things from the internet, and we can also do role. So we're going to do role, and we can see that we can initialize a role with init. And this is going to be within the base of the structure there. And the idea here is just going to set up the folder structure for us to effectively use the roles in Ansible. So we'll say init spine 01, 2, leave 01, 2, and 3. So now if I do a tree, we can see that we have a structure for each of our nodes, and this is going to let us deal with things differently there. I'm not going to get that advanced in this example there, but we're just going to mainly just do some tasks, and then we're going to do some Jenga templates there so that we have everything we need. But with that built, we can just go git add, and we're going to add all the files. I'm going to say git commit. Message is going to be added Ansible roles. And last, we'll just go git push. Now, if I go and pull those changes, we now have our folder structure. Now, because I'm going to use Jenga templates for this there to help templatize our configuration, we're going to first make the template. And the easiest way to do that is to pick on the first one, and then we're just going to create a directory. We call this template. Actually, templates. And we're just going to call this template J2. You don't have the right plugin for that, so I'm just going to click OK. It doesn't really matter. The template we're saying is we're going to loop through a list we're about to create called IP templates. But before we look at that, let's go ahead and create some variables. So let's go under main here. And here's our first interface there. I'm just doing leaf first because it's alphabetical and it's easier to keep track of. So what we have here is we have a test variable just playing around. And then we have a list called IP interfaces. And this is going to define each of our interfaces. And also it's going to add a description saying that configured by Ansible. And then we're also going to do the host name and the domain name. Then if we look at the template file, what we have here is that we're looping through each interface inside IP interfaces, which if we look here is these three. And then we're using the variables to fill in our configuration commands. So we can see that set interface, this would be Ethernet, ETH0, address, and then the IP address. And same with the description and so on and so forth. So basically everything that's a variable gets substituted by whatever's in the variable file. With that said, we can go ahead and copy the template folder. And we are going to paste that under each of these. Yes, there's more efficient ways to do that there, but we're more just having fun, aren't we? All right. So we've copied that there. And now what we're going to do is we're just going to make sure that we have the right variables in each one. For leaf 2, going to be this. For leaf 3, going to be this. And then our spines happen to be last because of alphabet, because it's alphabetical. And last and probably least, if we're being honest, spine 2. Okay, so now that everything's added, we are again going to, now that we have our Jenga template set up there, we actually have to make our tasks. So we're going to go to tasks, under main. We'll start here. And the beauty of doing the Jenga template there is we're all going to have pretty much the same task. They're all just going to say that we are running some VyOS config and we are pushing this template. I can actually just copy this and adjust the name of it as I go. We have the last spine, which is this guy. Okay, so now we have our structure down. Now the last thing we need to do is actually make that provision.yaml. We're going to go down to the top here and just go File. This is going to be provision.yaml. Now all this guy has to do is call the different rules there so that it runs on the right nodes. And what that looks like is we're saying we're going to run on all hosts. We're going to specify the network CLI. We're not going to gather any facts. And then all we do is we use the when statement to say that when it is spine 01, then go ahead and run the spine 01 rule and so on and so forth there. So this way, the individual configuration is going to apply on the right device. Now there's a lot more stuff we can do to clean this up and make this more efficient, but this will work for our purposes. So with all that said, I should be able to go push and say finalized Ansible config. So if I push all this and go back over here, I should now be able to say Vagrant up. And what I'm expecting is that when everything runs, it's going to provision the Ansible there, and we should have the full configuration that we're looking for. As this is running along, we can see that Ansible is running there, and because I enabled the random variable there, every time it wants to draw a cow art, it's going to be different. So we have a little dinosaur, and then when it's doing the spine there, we got some frogs, and then this is, I think it's a cat with a little bow tie thing. So basically every time it runs some kind of Ansible statement, it's going to have a different thing there. It just adds a lot of fun to the proceedings. Okay, that's all completed. So what we can do is do a vagrant stopped status. And we can see everything's running there. So we'll just connect to one of our spines. And now we're in here, we should be able to see our neighbors are fully up. And we can also look at our routing table, and we have our 3 loopbacks for our leaves and also our spine. Okay, so that worked the way it should. At this point of the video, we have everything configured automatically for us. We just had to press the up button and everything worked. But the thing we haven't tackled yet is that I downloaded the rolling configuration from VyOS there, but when a new version comes out, I'm going to have to remake the box and update everything manually there, which is not the point of this. So now we're going to talk about Packer, which is going to help us with that piece of the puzzle. Alright, the next tool we're going to talk about is Packer, which is also made by HashiCorp. And what this one does is it focuses on creating images for virtual machines. And it can also automate installs, which is kind of cool. Just like with Vagrant there, we have the same kind of install options. We can do Mac, Windows, Linux. It's basically the same steps across the board for all the products. Now for our case, we only need Packer on my Windows PC because we're just going to be working directly with my VirtualBox and we're not going to bother with the other operating systems. So I already have this installed because just like before, I've installed this with Choco. So I just do my Choco install Packer. You don't need to see that again. And we can dive into the configuration. So inside our Ruby, we are done with the Ansible portion, so we can just collapse all these folders. And we're actually going to do a bit of cleanup here. So I'm just going to say directory. I'm going to call this Ansible. And you're going to drag all this stuff into there. I am not going to search for references because otherwise it's going to try and rename any paths. And we're just going to go refactor. Now we have a nice clean folder for Ansible, and we're going to create another one for Packer. Now inside of Packer, I need 2 folders. I need HTTP, and I need ISO. Now the ISO is going to be used to download our VyOS ISO when we run the process there, and the HTTP is really just a catch-all folder for how you're supposed to use Packer there. I'm kind of doing this in a little bit of a different fashion. But for this to work, I'm just going to create an empty file called .getKeep. And the reason for this is that we can't upload empty folders to repositories because there's nothing to sync there. So we just put a simple file in there so that they get replicated properly. I'm going to copy this. And I'm going to paste this in ISO as well. And now we can work on our actual file. So I'm just going to right click and go new. Now I'm going to call this VyOS PKR package .hcl. Now HCL is HashiCorp's configuration language, and this is how we configure our most of the HashiCorp things there, like Terraform and that kind of thing. What I'm going to do is just copy and paste this, and then we'll talk about it. So at the top, I've defined some variables, and this is how it knows how to log into the device. You can see that I'm using the VyOS and the password I set when I first installed the imager. And then it has a number of parameters there, like I'm downloading the ISO, storing it in the ISO folder. I am not doing a checksum because it's supposed to change every day there, and we don't want my script to break. And then we're passing along how it's going to connect and that kind of thing. And actually, I don't need that HTTP server. I already moved it from my configuration, but it's not hurting anyone, so we'll just leave it. Now, the bulk of this is the boot command. What it's going to do is it's going to download the ISO and then create a VirtualBox VM. Then it's going to boot it, and then after the 60 seconds, it's going to log in by typing VyOS and then VyOS, and you see how I'm doing enter and waits there so that it's timed out properly. And it took me a bit of practice and trial and error to get this the way it needs to be, but this is going to go through, it's going to do the install, and then when we're done, it is going to reboot, and then we're going to wait another minute so that it comes up, and we're going to log in with my password that I set here. And then it's just a matter of pushing the keys like we did before there. So we see we have Vagrant. We're pushing the insecure key, and I'm basically just breaking it up so it's more readable there, because you see that there's the enter key. So I'm not actually hitting enter until I hit this line there. So this is actually just so that it's not way over here there. When you write files there, you don't want to go past this line for best practices, because otherwise it's poor form. But anyway, we have our SSH key. We have our tell this RSA key. We set the interface to DHCP, and then we commit. We save the configuration, and then we wait. So after that's done, Packer will connect. And because I did all my configuration here and we're doing everything else in Ansible, I didn't need to go further. But I could also use provisioners to push more configuration into the image so that it's more complete, but we're not going to bother with that. And then lastly, we're telling it that this is going to be a Vagrant box. What this is going to do is it's going to spit out a box file that we can use in our next phase so that it can automatically create the VMs for us in Vagrant. With all that said, I'm going to commit this, and we'll say adding Packer config and restructuring. By the way, it's always good form to at least have a little bit of notes there when you commit, even if it's just for a lab. So we're just going to go push. And that'll be ready for the future. What we're going to do is we're going to open up this directory. And we're just going to say cd packer. Then we're going to say build and pick that file. You can see that this is downloading the ISO for us. And I need to delete my old template here. So I'm just going to go. Oh, I forgot to delete these two. So let me just clear this up a bit. And we will delete this. Okay, now that's cleaned up, let's just go back over here. And we'll try the building. So I'll show you this because this is actually pretty cool. I'm just going to go view, just like 200%. And we can see it's typing. This is not me, this is just the magic of Packer. So you can see that's pushing up that long key that I split up into multiple lines as one continuous command. And once it commits, it's saving the configuration. And we can see that it is now connected with SSH. It's now going to stop the VM. If we look here, my completed provisioner is running. That is this guy here. And this just let me know that things went okay and it was able to connect. And now what it's going to do is it's going to export the machine, it's going to create a box, and that's all Packer is going to be doing for us there. But you can do a lot of really neat stuff with the tool. So we can see we now have the Packer VyOS VirtualBox.box there. Now we're going to stop it here, and then in the next part, we're going to look at the GitLab CI/CD to bring us home. The last main topic we're going to talk about today is continuous integration and continuous deployment. We're going to use this to glue our components together. We used Packer to create an image. We used Vagrant to provision the VMs. And now we're going to use GitLab CI/CD to detect when there's being a push to the repository or a trigger. And then it's going to execute all the actions for us. So in our GitLab, I've been uploading our changes all along there. That's how I've been moving files between my computer and my WSL. So for example, if we look under Ansible, we have our Ansible files. And under Packer, we have our Packer files. To do CI/CD, we need to create a particular file. And we can have a look at that by going to CI/CD. And we can have a look at that just by adding a file. And this is going to be gitlab-ci.yaml. To get us started, we can pick from a number of templates here. So for example, if I click on the Python one, it is going to show us how to make the stages and how to do individual tests there. What I'm actually going to do is just wipe this out. And then I'll commit it. So we can see that it's saying this configuration is valid right now, but I'm going to populate this in my Ruby mine. So go back over here and we'll close all these files we don't need anymore. And then we're just going to go git, and we're going to pull the latest version. We now have the gitlab-ci.yaml, and there's nothing in it. The way this works is we first define our stages. So we're going to have two stages in this project. So we'll say stages, and we'll say Packer and Vagrant. Basically, we're going to pack the image first, and then we're going to actually use that image in Vagrant to deploy it. Now we have our stages, we have to start getting into the individual steps. So the first step we're going to do is we're going to work on creating the box file. So we're going to say create box. And inside the step, the first thing we need to do is pick a runner. So with GitLab and any other kind of solution there, we can install an agent on our on-prem equipment. And this is going to let them execute commands locally so that we can build things internally without having to use VM resources. If I don't define a tag, it's going to be run as what's called a shared runner. And that means it's just going to build up a cloud instance and do what it needs to do. But we don't have VirtualBox and all this stuff installed on the cloud, so it's going to be useless to us. So I have already registered my MacBook as a runner. And we can see that by going back over to GitLab here. And if we go to Settings, CI/CD, then Runners, what I'm actually going to do is use my MacBook to register as a runner. So that's going to be called Tags, MacBook Pro, and Shell, because I want to be running as a shell there. I'll show you what this looks like on the other side in a minute. I was going to use WSL to finish this off there, but apparently the Packer WSL integration isn't quite there yet there, so we'll just switch over to my MacBook. And it also kind of shows you that the code is somewhat versatile. So now we have the tags. We need to say that this is part of the Packer stage. We can define an environment to run in, and this is just isolated environment inside of GitLab. I'm just going to call this production. Then for the actual script that runs, we want to say Packer build. And we're going to use the force tag here just because we're automating this there and we don't want to have this stop if we didn't clean up the previous build. And then that will be under Packer, and it was called VyOS Packer HCL. That is this guy here. So we're pushing the Packer command. Now what we want to do is some cleanup. So we're just going to say remove the VyOS folder in the temp directory. And then we're going to create one. So what this is going to do is just make sure that our directory is always empty. Then I'm going to copy the packer, this guy, to VyOS.box. So it's a nice, easy name. And then we're going to copy the VyOS files to that temp directory. And while we're at it, I'm going to make a new JSON file before I forget. So we're just going to go here. And we're going to call this VyOS.json. And we're going to paste it in there. We're just really pointing it to that temp directory. Okay, back to our file here. All right, so that's our first step done. And now what we need to do is we need to work on adding the box into the configuration. So that's going to be a new step. That's going to be add box. It's going to be the same runner. And we can have several different runners doing things there. We can have multiple ones doing at the same time. Depends on what your design is. We're just keeping this simple. We're just doing this for a fun little running lab. And in fact, we can copy all that stuff. So for the stage, it will be Vagrant. Now this time, the script will be to make sure the VyOS plugin is installed. So we'll say plugin install Vagrant VyOS. Remember, this is so that the Vagrant can detect the VyOS OS. And then we're going to say Vagrant box add. We're going to force it just in case it's already there. And we're going to say temp VyOS, VyOS.json, which is here. The box is also going to be added to the root, and then they're going to be moved. So now we have that done. The last thing to do, let's copy all this. Last thing to do is to say, we'll call it Gitlab. There we go. So it's going to be Vagrant production. And this time, all we do is say, and this time, we want to copy the playbook files from here because this is going to be running in a temporary directory. And we want it easy for us to actually manage the Vagrant when this is up. I'm just going to say copy Ansible -r, so it's recursive, to temp VyOS. There we go. And then lastly, we just say cd into that directory and Vagrant. So what we're basically saying is move into that directory, and then we're going to bring up the Vagrant. And because we're in that directory, it's going to have all the hidden subfolders and whatnot there, so I can manage it from this folder. If I don't do this, what's going to happen is going to be in that temporary directory, and this is all going to get destroyed when the sequence is complete there. So that's why I moved the files into a temp folder over here, because it's easier to maintain it there rather than mess around with dependencies and whatnot to keep it going. So it's just because we're kind of messing around with this a bit there. Usually you don't use this to build up persistent lab there. You use it for testing to make sure your code is good, and then you execute elsewhere. But we're just having fun. All right, I think this is fun. I don't know if anyone's still listening at this point, but I don't know. I had a good day. Alrighty. So now that's all done, I'm going to commit this. I'm going to say adding CI/CD. And just by the fact that this file exists, when I push this, and I go to pipelines, you can see that it tried to build, and apparently my YAML is in fire as an error. So let me just have a look here. Apparently I have a typo in what I wrote there. When you work with YAML, you usually have some kind of spacing issue there. So let's just look at CI lint. And let me just copy what I have. And we'll see what it's angry about, if anything. We'll go validate. All right, to see if my spacing is off a bit, we'll go validate. Okay, I just had a bit of white space there, so let me just copy this and put this back over to my thing here. And we'll just go say submit. Correcting white space. And we'll push. This is going to trigger the pipeline again. And this time, it is in a pending state. And the reason why is I declared a runner, but I haven't actually added the Mac yet because this is a new project and runners are specific to projects there unless you make a shared one. So you see we have the steps defined. So we have the Packer, the Vagrant, and then we have the crate box, app box. I can split this up as much as it makes sense to me, but this is enough for our purposes. So what I'm going to do is I'm going to hop over to the Mac and we're going to finish up on there. So the first thing I need to do is use sudo to access the system mode and then type gitlab-runner and then register. And I just type in my sudo password. And because I'm using the cloud application, I just type gitlab.com. If I had a private server, I would type in that address. And then I paste in the registration token. You have the description so I can find it later. And then I enter the same tag I entered in the CI/CD. Now for the executor, I'm just going to use shell, but there's many other options for other scenarios. And then I'm just going to go ahead and restart the agent. All right, now that my runner is registered, we can see that this is now running. And if we look, we can see the progress as it goes. So we can see that this is in the middle of doing the Packer there. It is doing its boot commands. And if we check back in a few minutes there, we should have a completed pipeline. All right, so back on my Mac, everything is completed. So let's just check out by running a Vagrant status. And we can see we have our 5 VMs as expected. And now I'm going to SSH into the spine. Now you notice that because I'm doing this from the Mac there, I don't have any issues with the SSH keys like I did with the WSL, so something to keep in mind. But we can see our neighbors are up and our routes are up as expected, so this is working without us actually having to touch anything. Perfect. Alright, well now we have everything working the way we want it to there. We have our Packer pulling the current image off VyOS there. We're building 5 VMs and then we're pre-configuring them with Ansible. The last thing we're going to do tonight is use Alexa to trigger the build. And we're going to do that by defining triggers. What a trigger is it allows you to send an API request to GitLab, and when you do that, it knows to trigger a build. So under pipeline triggers here, I'm just going to give this a description. Actually, that works for me. I'm just going to use one of my history here. And we can see that when I click add trigger, it is going to give me a token, and then it's going to give me some examples how to use this. So what I'm going to do is just grab the token here. And you would also want to take note of the project ID, but I already have that written down. And I'm going to go over to my Postman and open up a GitLab I have. So what we have here is I have my project already defined, and I have a field for the token, which I now need to update. So we're just going to go here and update the token. And now the token is ready to go. So I am going to use the code generation to get this handy. So I'm just going to go ahead and copy all this. And I'm just going to delete that. And we don't need anything but payload or headers. There we go. So I'm just going to copy this configuration. And we're going to head over to the Alexa portal. Now inside the Alexa portal, I'm going to go ahead and create a skill. And I'm just going to call this lab control. Now for my locale, I'm just going to say that this is Canada. We don't need to worry about any locale stuff there, but basically this is where your skill will end up in their skill store, just like an Apple. Just like with the Apple App Store, if you have a Canada app, you can't necessarily have it in the US app unless you get export approval and that kind of stuff. So anyway, we're just going to do a custom app, and I'm going to just use Python. So we're going to create a skill, and we're going to start from scratch. So it's going to take a minute to put together. And we're just going to walk through the steps here. So first we need to work on the invocation name, and this is what we say to start Alexa. Now I see that the actual app name I said was lab control, but we need two names, so I'm just going to put a space between them. There we go. And then we need to have intents. Intents are how you actually control the app there, and they're the phrases that you say. So we can see there's like a hello world app that we're not going to worry about. In fact, we're just going to go ahead and delete that intent. And we're going to add our own. We're just going to call this lab start intent. And we can say things like start lab, start my lab, and let's say make it rain. Now I have my start lab phrases. Now I'm not going to bother doing the stop lab side. It's pretty similar and you get the idea. So now we're happy with all that, we're just going to go ahead and build the model. And this is going to build the back end there so that it knows to listen to these phrases, and then we can start working on our code. Okay, so now that's sorted out, we can go over to the code tab, and this is an IDE they provide that you can edit the code. Now the first thing we need to do is we need to import requests so that we can do our API call. And then we're going to change the hello world here to lab start, and that's good enough. And then what you have to do is find the hello world. And how this works is the class will listen to what's being said. Actually, here's the starter. So how it works is this class will be handled first there, and it is going to listen for what it is and see if it matches any of the uttered phrases. And then it is going to welcome us to the app there. So we say welcome, you can say hello or help, and that's what you can try. We're going to change to something more fun. We'll say all hail the mighty packet thrower. We'll say, what do you want to do to your lab? Now we have that. So when we open the application, this is going to play. Now we actually have to do something. So what we're going to do is change this to lab start. So this is what's called on the bottom there, where it's calling the different classes. So go back up to the top. Too far. There we go. So we're going to say that this is for the lab start intent. And what we need to do is change this to be lab start. And actually, that's lab start intent. So basically, it is going to check to see if any of the phrases that I added to this intent are uttered. Those are called utterances. And if it is, it's going to do this. So we don't want to say hello world. We're going to say starting lab. And then all we're going to do is go over to here and copy this. And paste this right here. Now we're going to do our API call, which should trigger our build and say starting lab. And then if I wanted to stop the lab, I'd do something similar, except for I'd make it so the trigger does some actions that actually tear down the lab instead. So with all that in place, we go deploy, and this will take a minute. Okay, so now that code is pushed, I have also enabled it in my Alexa app on my phone. So now I should be able to say, Alexa, start lab control.
All hail the mighty packet thrower. What do you want to do to your lab?
Make it rain.
Starting lab.
And with that, I should be able to go over to CI/CD. And we see that a build is starting. So we talked about quite a lot of stuff today. We talked about Vagrant and creating VMs. We talked about Packer and how to create images. We played with Ansible. We did some CI/CD stuff. And then we topped up with Alexa. Hopefully you guys found it interesting there. This is ultimately just a drop in the bucket there when we start talking about things like NetDevOps or some of its other subsidiaries. But I figured it'd be a decent comeback video. So hopefully I see you guys soon.